6x5 talks about the inverse trigonometric functions. To talk about an inverse function, we need to make sure that the function is one-to-one. And if we look at a graph of a sine, wave, we know that runs between y equal 1 and y equal negative 1. And we know how it runs. It's one of those and one of those. We know this is pi over 2, that's pi, that's negative pi over 2, that's negative pi. And this is what we know. We notice that if we start moving to the right, so again, this is definitely not one-to-one. You notice there are infinite amount of intersections, so that's not going to work. For me to talk about an inverse, the function must be one-to-one, so I need to restrict the domain. So in this case, I noticed that I could move to the right all the way to pi over 2. If I exceed pi over 2, then that would not be one-to-one. So I could start at 0 and I could run all the way to pi over 2. I cannot exceed pi over 2. And if I move in a negative rotation, I could move as far as negative pi over 2. And if I exceed that by even a bit, that wouldn't be one-to-one. So if I'm talking about the sine could be anywhere. But if I'm talking about the inverse sine of a value, then I could only be in quadrant 1 if it's positive, and in quadrant 4, but in negative rotation if it's negative. So an inverse sine value will either give a positive angle or a negative angle. The positive angle must be between 0 and pi over 2, and the negative angle must be between 0 and negative pi over 2. This one wouldn't be that bad if all of the trig functions would have matched. When I look at y equal tangent, that does match. Because if I look at a graph of a tangent, well, I notice for the tangent, I could move as far as pi over 2 or negative pi over 2. And a tangent looks like this. If I sketch another period, well, I notice now if I draw a horizontal line, it crosses more than once. So what I need to do, I need to ensure that I don't do that. I need to ensure that I could restrict x to run between pi over 2 and negative pi over 2, kind of like what we just did with the sine. So if I'm talking about an inverse tangent, then I would know that this matches the previous conditions. That is, it is positive in quadrant 1 because that's 0 to positive pi over 2, matches quadrant 1, and this is negative rotation to negative pi over 2. Again, that's not bad because they match, but if I look at the cosine, and this is where the trouble comes in. A cosine wave if I was able to restrict it between quadrant 1 and 4, positive and negative rotation, this wouldn't be that bad. If I am to sketch a graph, I know this is pi over 2, this is pi, this is 3 pi over 2, and so on, and this is negative pi over 2. But if I was to restrict it between negative pi over 2 and pi over 2, that wouldn't be one-to-one. That would be a problem. Rather, I could move to pi, to pi over 2. So if I'm running an inverse cosine, I could start at 0 and run to pi over 2. That's not a problem. and I could continue on beyond pi over 2 all the way to pi. So the inverse cosine is bound between 0 and pi, positive in quadrant 1 and negative in quadrant 2. I can't be in quadrant 3 or 4 because I can't exceed the pi over 2 or the 0. So the idea is we gotta get used to this. Sine and tangent are either in quadrant 1 or in quadrant 4, positive or negative rotation. That's inverse, of course. Inverse cosine is between 0 and pi, positive in quadrant 1, negative in quadrant 2. Keep that in mind, and let's see how this works. So this is an angle. I'm being asked to find the sine of which angle gives me radical 2 over 2. Call that theta, right? So I'm looking for, if I call this theta, where does the sine of theta equal radical 2 over 2? Well, I know the reference angle. The reference angle is pi over 4. And all what you have to keep in mind is, if they're all positive, you're always in quadrant 1, and you just give, in quadrant 1, it's always the reference angle. Done deal. How about inverse tangent of 1? If I call this theta, the same deal happens. That's really asking, what did you take the tangent of? That's asking, what did you take the tangent of to get a 1? Well, we know the reference angle is also pi over 4 because tangent of pi over 4 is 1. And if it's positive, I'm in quadrant 1, so it's always either the reference angle, or if it's inverse sine, inverse cosine, inverse tangent, negative that if this is negative, and if it's inverse cosine, quadrant 1 or quadrant 2. So let's get to this part. This is a special angle. We know that. This is always an angle. That's the only thing an inverse would really represent for us. If I look at, where does cosine equal negative 1? Well, cosine equal negative 1 right there. And how would that be? Based on what we said, you could run between 0 and pi. Wouldn't that angle be pi? Isn't the cosine of pi negative 1? What about if I'm looking at this? Again, this is a special case. If I draw my unit circle, I know sine is negative 1 right there. The temptation is to say 3 pi over 2. You can't. Why is that? Because 3 pi over 2, you must exceed the pi over 2 limit. You're not allowed to. Instead, you run in negative rotation to that point, and that would be negative pi over 2. So, if the value of the inverse is negative, you must be running in negative rotation for inverse sine, inverse tangent. How about E? If I call this theta, I'm looking for 0 equaling the tan of theta. Where does tan equal 0? Tan equals 0 in few places. We know tan equals 0 right there and right there. Since this is off limits, the answer must be 0. The tangent of 0 degrees or 0 radians is 0. This is also a special case. So I'm taking on all the cases. I'm looking for this being theta, so I'm asking, where does cosine of theta equal 1? Well, we know cosine of theta equal 1 right there. That's when theta is 0. Again, these are angles. Keep that in mind. This is an angle. So this is a special triangle. What's the reference angle? The tangent of which angle gives me radical 3? The tangent of 60 degrees is the opposite over the hypotenuse. 60 degrees is pi over 3. And since this is negative, guess what? If it's inverse tangent, my answer is either in quadrant 1, positive rotation, or negative rotation, that's negative pi over 3. So the outcome of an inverse tangent is either an angle that is between 0 and pi, or 0 and negative pi. Same thing with inverse sine. If I call this theta, I'm looking for negative 1/2 equal the sine of theta. Ignore the minus. Look at this triangle. Sine of which angle equal 1/2? Sine of 60. And since it's negative, that's going to be negative pi over 3. If I move to the next set of problems, well, how about here? If I call this theta, then I'm really looking for negative 1/2 equal the cosine of theta. Well, the reference angle, there's the triangle, cosine of, oh, did I mess up on this one? Yeah, I did mess up on this one. The sine of which angle gives me 1/2? The sine of 30 degrees. Pi over 6, my mistake. And my answer is either pi over 6 or negative pi over 6. Before I start, inverse cosine is either 0 to pi over 2 if it's positive, and if it's negative, I want that angle in quadrant 2. Well, it is negative. The reference angle is pi over 3, 60 degrees. Since it's negative, I am in the second quadrant. What's pi over 3 in the second quadrant? 2 pi over 3. And that would be my answer. How about here? What's the reference angle? If I call this theta, I'm looking for negative 1 equal the tan of theta. Forget the negative. The reference angle, tangent of which angle equal 1 pi over 4. You could draw the triangle if you wish. And since I'm looking at a negative value, positive in quadrant 1, or since it's negative and you are in quadrant 4, negative pi over 4. Temptation to say 7 pi over 4, you can't. You can't exceed pi over 2. How about this problem? It's asking the sine of which angle equals 0. That's a special case. We know sine equals 0 right there and right there, but since it's an inverse sine, it has to be 0. And if I look at this and call this theta, I'm looking for negative radical 3 over 2 equal cosine of theta. I want the reference angle. The reference angle in the triangle is right. I could draw it again. It doesn't take long. The cosine of which angle gives me radical 3 over 2, 30 degrees, or pi over 6. But since it's negative, I know I am in quadrant 2. What is pi over 6 in quadrant 2? 5 pi over 6. And that would be my final answer. Now, what if they didn't give me an angle? They want a cosine. Look at the outsidemost function. When I take the cosine of a quantity, right, isn't this an angle? So I'm really looking for the cosine of this angle theta. And I know what that is. That is the adjacent over the hypotenuse. So it's a ratio. I'll go on the side and I'll say, well, look, if theta equal the inverse sine of 1 over 3, that means the sine of theta must have been 1/3. I could create the triangle and figure this out. I need to know which quadrant am I in. Well, inverse sine is positive only in quadrant 1. You can't be in quadrant 2. So there's theta. Opposite over hypotenuse. That makes this the square root of 9 minus 1, 8, and it's positive. I want the cosine of that, adjacent over hypotenuse. And that's how we do all of these problems. Let me look at yep, I have a lot of them. And let me look at one more before I conclude this video. and start this on another video. What would be the difference between A and B? They look very much alike. Well, I'm looking for a ratio. A cosine of an angle is a ratio. This is always an angle. That's the only thing that it could represent. That's the cosine of theta. And again, I know what that is. That's the adjacent over the hypotenuse. I need to create the triangle. It's not a standard angle. So, where is... Let me go ahead and write that out. If theta equal the inverse sine of negative 1/3, that means the sine of theta equal negative 1/3. Which quadrant am I in? Well, sine is negative in quadrant 3 or 4, but since this is an inverse, you're only allowed to be in quadrant 1 or 4. My angle must be in quadrant 4. Opposite over hypotenuse, this is negative. This turns out to be radical 8, which is 2 radical 2. What's the cosine of that? The cosine of that is the adjacent over the hypotenuse. The cosine doesn't change. There it is. Now I'm going to stop this video here and continue in another video.